wabarakatuh. Hi 11 graders, how are you today? Good? Alhamdulillah. Okay, welcome to my video. In this video, we are going to discuss about vector addition. Before we start the discussion, I would like to give you a question. This is the question. You have 2 kilograms of apples, and then your mother is giving you more 3 kilograms. And my question, how many kilograms that you have of the apple? Yes, that's correct, yeah, 5 kilograms. That's correct. And then, okay, maybe I revise my question. I have 2 questions for you. Okay, before we discuss the first one, I have this second question. This second question is like this. You're traveling to the west, yeah, 1 kilometer, let's say 1 kilometer to the west, and then you continue your travel to the north for 2 kilometers, let's say. And then my question, what is the distance from your starting point to the ending point? Okay, I think this one is more difficult, right? Yes. Okay, the first one, talking about the mass, because mass is just a scalar vector, scalar quantity. Okay, maybe you already know what is scalar quantity. Scalar quantity, that means this quantity only has it only has magnitude without no direction. Mass, 1 kilogram, 2 kilogram. Is there any direction? 1 kilogram to the north, 1 kilogram to downward. It doesn't make sense, right? So that's scalar quantity. So to add some scalar quantity, we can just simply add the magnitude. 2 kilogram by adding by 3 kilograms, so the total will be 5 kilograms. That's all. It's very easy. But then the second question is not easy. Yeah, it seems not easy, but after watch this video, I'm sure you can answer this question. 1 kilometer to the west, yeah, that's displacement. Displacement is a vector quantity. As I said, 1 kilometer to the west, there is magnitude 1 kilometer, and there is there is the direction to the west, yeah. And then 2 kilometer to the north, yeah, again magnitude and direction. That's vector quantity. Vector quantity not only has the magnitude, but it also has direction. So that's why to add this vector quantity is not as simple when we do addition in scalar quantity. Now, so in this video we are going to discuss how we do addition in vector quantity. And if you are interested watching this, if you are interested in this topic, please continue watching until the end of this video. And let's start the video by reciting basmalah. Bismillahirrahmanirrahim. Yeah, check it out. Okay, everyone, now I'm already open a simulation from FAT again here. The simulation is about vector addition, of course. That's the topic that we are going to discuss in this video. Okay, in the main menu here we have 4 options. Let's just choose the first one. Okay, explore 1D. Okay, let me to make it in default like this. Alright, in the introduction, I said that a vector quantity not only has magnitude, but it also has direction. And how to represent a vector quantity, we can use an arrow, okay, like this. Now, yeah, when we draw an arrow like this, okay, now, so that's mean the magnitude, yeah, is 5, yeah, according to this scale, yeah. The magnitude is 5. We can also click this one value, yeah, to show the value of this vector quantity. The value or the magnitude is 5, and then the direction, as you can see, the arrow is directed to the right. So the magnitude is 5 and the direction is to the right. Okay, yeah, that is how we represent a vector quantity using an arrow. So the length of the arrow will represent the magnitude like this. Okay, Yeah, the longer of the arrow, that's mean the higher, yeah, of the magnitude. Okay, and then for the direction, it's depend on the arrow direction, of course, yeah. Okay, for now I set the magnitude as 10. Okay, yeah, 10. And then I will draw one more. I will draw one more vector quantity here, and the direction is to the left. Yeah, the direction is to the left, and the magnitude, let me set as 5. Okay, yeah. Now, so for example, yeah, you can imagine we have a box. We have a box, and then we pull the box by a force 10 Newton to the right, and the force is represented by the first arrow, yeah, arrow A. Okay, and then the box also is pulled to the left by a force of 5 Newton, yeah, to the left, and the force is symbolized by B here. Okay, yeah, so you can imagine we have a box that fall into two direction, left and right, but by different value, yeah, of the force, 10 and 5. And then what is the resultant? What is the resultant? Okay, for this one, it's very simple because it's pull to the right 10 Newton and then 5 Newton to the left, so it will be simple. The resultant will be 5 Newton to the left, sorry, 5 Newton to the right. Yeah, 5 Newton to the right. We can just simply subtract the higher one to the lower one. Yeah, 10 minus 5 is 5. Okay, we can show the resultant by tick this one, sum. Okay, you see the darker blue here, it show the resultant. Yeah, it show the resultant. It's 5, but I'm sorry, the what is it? The text is overlapping. Yeah, but it show us that the magnitude of the resultant is 5 Newton to the right. Okay, yeah. Okay, and then what if the force that directed to the left is higher, like this? Let's say 20. That's the force to the left, 20. The force to the right is just 10. So what is the resultant? Okay, try to answer, everyone. Yes, that's correct. Yeah, it's simple. 20 minus 10. So the resultant will be 10 because the higher forces is directed to the left, so the resultant direction will be also to the left. Okay, let me show you by take this one. Okay, you see here? Yeah, the darker blue arrow show us the resultant. Yeah, and it's directed to the left, and it's written here the magnitude 10 newtons. Now, so basically it's, yeah, for addition force or addition vector that's only in one direction. Yeah, all right. Now let me show you how to do addition of vector when it's not in a line, horizontal or vertical, but it's what is it? It's occupy a plane like this. For example, I have a vector here that's directed to the right. Okay, let me show you the value. Okay, it's 15. Let's say this is a force, yeah, to make it easy for this discussion. 15 Newton to the right. And then I have another force. And the force, yeah, it's directed to upward like this. Yeah, upward. Okay, let me set the magnitude different. Okay, let's say the upward force is only 10 Newton. So we can imagine we have a box. Yeah, we have a box that is pulled to the right by 15 Newton of force, and it's also pulled to the upward by 10 Newton of force. And then the question, the same, what is the resultant? what is the resultant. Now to find the resultant, yeah, to find the resultant, we can just simply what is it, we can just simply from the end of the first force, yeah, we can draw a dash line, yeah, vertical here. Okay, but in the simulation I cannot do that, yeah. So just imagine we have a dash line vertical starting from the end of this arrow. Okay, and then we have to also draw a dash line starting from the end of the second force, and it's horizontal, yeah, from this point to this horizontal line, yeah, and the two dash line will have intersection here, yeah, it will overlap here. Now so from this point we can make a line to the box, yeah, we can make a line to the box or to the original coordinate, yeah, in this Cartesian coordinate. So we will get the resultant, and then we can use a ruler, yeah, to measure how is the length of the arrow. Yeah, let me show the arrow. Okay, this is the arrow, and when I drag, okay, sorry, yeah, when I put the arrow here, okay, that's perfect, yeah, starting from the intersection between the two dash line to the what is it, to the box, yeah, or to the original coordinate here. Okay, now yeah, basically in this video I'm showing you how to do addition of factor using graph, yeah, using graph. It's relatively easier, yeah, everyone, but here we have to draw in a perfect, I mean you have to consider about the scale. If the force is 15 Newton and you draw the force by 15 centimeter, so when you draw a force of 10 Newton, you have to draw it in 10 centimeter. So you have to draw it in scale. Yeah, in scale. So you will get the correct answer for the resultant. All right, yeah, get it, everyone? This is how to find a resultant force, yeah, in a coplanar. Yeah, that's mean in a plane, in the same plane. Okay. Yeah, basically it will be the same. Yeah, let me show you another example. Okay, I drag the zero coordinate to the middle. Okay, I have a force, let's say, directed to this direction. Yeah, make an angle 45 degrees. So you have to draw it, yeah, using your spectator to make sure that the angle is 45. Okay, and then I have of another force that's directed to this. Okay, yeah, let me show the values. Okay, this one 14.1 and this one 10. Okay, what's the resultant? Yeah, basically for this one basically the same, yeah. uh, from from the end of the first force, you have to redraw the second force, and the magnitude and also the direction should be the same, yeah. So it will be to the left, yeah, to the left 10 Newton, or when we using this graph method, and 10 Newton for 10 centimeters, so you have to draw 10 centimeter of arrow, yeah, to the left here. And then after that you have to also redraw, yeah, redraw the first forces, yeah, starting from the end of the second force, yeah. So you have to draw from this, and you have to draw the first forces the same direction and the same magnitude, and then you will get the intersection, yeah, you will get the intersection. So will be the resultant. All right, yeah, will be the resultant, yeah. Okay, let me, sorry. Okay, yeah, so this is will be the resultant. Okay, you can imagine the dash line or the second drawing for the two forces. Starting from this point, yeah, the end of the second force, you redraw the first force. Yeah, it will be directed to this point, right? It will be directed to this point. And then starting from the end of the first force, and you redraw the second force, yeah, with the same magnitude and also the same direction, it will be directed to this point also. Yeah, so you will have the intersection here. And again, from this intersection, you can just draw a force or an arrow to the center here. Yeah, so we will get the resultant. Okay, get it everyone? So it will be easier actually when we use a graph method in finding the resultant. Okay, the last one I would like to show you. Okay, here I would like to show you how we how we determine the vector component when we have a vector that's not in line or parallel with x or y axis. Yeah, like this. Okay, yeah, like this. Okay, let's say I set the vector like this. Let me show the value. Okay, the value is 21.2. Yeah, 21.2. To find the vector component that's mean because this vector is not parallel, yeah, to the y and also x-axis, so it has the impact, yeah, to the x-axis and y-axis. Yeah, let's say this vector is velocity, yeah, as the stated here, v, velocity. So let's say a car is traveling to this direction, yeah, to this direction, 45 degree, and the velocity is 21.2. Okay, and then we have this b coordinate. Now, and then after the car stop here, so we can determine, yeah, the displacement in x and also y axis. Yeah, and the result of the trip, the displacement in y axis is increased and the displacement in the x axis is also increased. Now, so that means the velocity in this direction has impact, yeah, to the x and also y axis. And the question, how much is the impact? Yeah, now, so here we have a term vector component. Now, how to find the vector component of this vector? Yeah, basically it's easy. Yeah, you only need to draw a dash line, yeah, from the end of this arrow to the x-axis, and then you will meet the x-axis at this point. Yeah, and okay, at this point, so from this point you can draw an arrow, yeah, from the original point. So that's the vector component in x-axis. And for the y-axis, the same, starting from the end of the force, yeah, from the end of the arrow, you can draw a dash line, yeah, to the y-axis, and you will meet the y-axis at this point. Yeah, so you can draw an arrow, yeah, from this point to the original coordinate. Okay, and then that's the vector component in y-axis. Okay, in this simulation, how to show it, you can just simply click this one. Yeah, you see, yeah, this is the vector component. This is the vector component in y-axis and x-axis. Yeah, 15 and 15. Okay, so this vector component can be used when we are going to to find the resultant, yeah, of this, of some forces. Let me show you here. I have another force. Okay, I have another force and directed to this point, yeah, let's say. Okay, this second force is this second vector is 11.2. Yeah, and when we draw to find the vector component, we get 10 and 5. Yeah, 10 in x-axis, 5 in the y-axis. So to find the resultant from these two vector, yeah, from these two vectors, we can simply add, yeah. For the x-axis, we have 10 and 15, which is 25. And for the y-axis, we have 15 and 5, yeah, which is 10. Okay. 20. I mean, yeah, 15 and 5 is 20. So to find the resultant, we can use the Pythagoras formula, yeah, to find the hypotenuse, yeah, when the side is 25 and 20. Okay, so we will get the resultant. All right, that's all, everyone. Okay, that's all, everyone. Yeah, that's the discussion of vector addition. I hope this video can be helpful for you to understand the topic. And to summarize the topic, let me just say that quantity has two categories. Yeah, based on the direction, we have scalar and vector quantity. To add vector quantity is not as simple when we add scalar quantity, so you have to consider about the direction, and in this video you have watched it. I hope you understand, everyone. And also remember, we have also vector component. It will be helpful for you when we are finding the resultant of the vector. Alright, okay, again, thank you for watching, everyone, for this video. But if you are still confused or you have more advanced question, please do not hesitate to deliver your question to me. You can deliver it through WhatsApp, yeah, or maybe in the class discussion. Okay, again, thank you. Let's close this session by, not this session, let's close this video by reciting Hamdalah. Alhamdulillahirabbil alamin. Okay, see you in the next video. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.